so now we would like to evaluate. So what we have done so far, we looked at a dagger acting on n is equal to square root of n plus 1 into state n plus 1, a acting on n square root of n into n minus 1. Okay, so now let's evaluate the matrix element n prime a n, which is equal to square root of n into state n prime n minus 1, or this is equal to square root of n into delta n prime n minus 1. Okay. Similarly, you can evaluate n prime a dagger. This is equal to square root of n plus 1 n prime n plus 1, that is equal to square root of n plus 1 into delta n prime n plus 1. Okay. So we've done this. So now let's do one thing. So what is of a? The definition of a is square root of m omega divided by 2 h cut x plus ip divided by m omega, and a dagger is equal to square root of m omega divided by 2 h cut x minus ip divided by m. Right? So now we can just find x and p in terms of a and a dagger. So we just add these two. So we get a plus a dagger, which is equal to square root of m omega divided by 2 h cut into 2x, right? So which you can write it as 2m omega square root of 2m omega divided by x cut into right. Let's do it. A plus a dagger, which is equal to m omega divided by 2x cut into 2x. So this root 2 square. So you get that's 2m omega divided by x cut x into x, or x is equal to square root of h cut divided by 2m omega into a plus a dagger. Similarly, you can subtract a minus a dagger. So a minus a dagger, which will be equal to square root of m omega divided by 2 h cut. This cancel off, and we'll have 2ip into 2ip divided by m omega. Okay, so that will give you square root of 2, and the 2 there, and this 2 and the square root of 2 and half of, and there will be h cut and then m omega into ip, right? Or you can say that p is equal to square root of h cut m omega divided by 2 into a minus a dagger, and that I has to come to this side, that will become minus I. So you have an I here, and you can write a dagger minus a dagger minus a. So x is this, comma, p is equal to I into square root of h cut m omega divided by 2 into a dagger minus a. This is alright. So now let's try to figure out what is I didn't get it. Okay, this is actually, I need this. So this was my n prime a n, and this is n prime a dagger, right? So I can write that here. I can write this n prime a n, which is equal to square root of n into delta n prime n minus 1, n prime a dagger n square root of n plus 1 delta n prime n plus 1. Okay. So now let's try to figure out what is n prime x n, that is equal to n prime x is this quantity, right? So you will have you can pull out the factor square root of h cut by 2m omega into n prime a plus a dagger into m, which is square root of h cut divided by 2m omega into n prime a n, that is nothing but root of n square root of n delta n prime n minus 1 and then plus square root of n plus 1 square root of n plus 1 delta n prime n minus 1. So n plus 1. Yeah, square root of n plus 1. And similarly, you can evaluate n prime Pn. Again, that is equal to, then there is an I coming out, I into square root of h cut m omega divided by 2 into n prime a dagger minus a n, which is equal to I into square root of h cut by m, h cut m omega divided by 2 into n prime a dagger n is square root of n plus 1 delta n prime n plus 1 minus a is square root of n delta n prime n minus 1. So this is n prime Pn, and this is n prime Xn. Okay, now I give an exercise for you. The exercise is following. You have to, okay, exercise is following. What you need to do is, you have to find the matrix representation. The matrix representation, I mean explicit matrix form, and you have to get the explicit matrix form for A dagger, X, P, and 1, 2, 3, 4. You have to get all the matrix form, I mean, of A dagger, X, and P in the n basis. So you get a matrix, and remember that all these matrices will be infinite dimensional matrices. So you have to find that those matrices. Okay. So that's the exercise for you. So now we go and evaluate the wave function. Okay. The eigenfunctions of this harmonic oscillator. So that's all right. We know that, I mean, if what is x prime 0? Okay, x prime 0 is basically, this is the, you can say that psi 0 of x, your wave function, right? Psi 0 of x in terms of wave function, you can say that. So I mean, of course you know that, and so you need to, the first what we do is x prime a 0. But A acting on 0 will be 0, so this will be 0, right? But I know this is equal to x prime. What is A? A is square root of m omega, so you can pull that out. Square root of m omega divided by 2 h cut into x prime x plus ip divided by m omega at 0, and this must be 0. Right? So you can forget this, right? So this is equal to 0. And you know that x acting on x is a Hermitian operator, x acting on x prime is nothing but x prime. So you get x prime into x prime x prime 0 plus you will get I divided by m omega, and then you get x prime p0. But we know from the first module x prime p0 is nothing but minus I h cut del by del x prime of x prime 0. Right? So you can substitute it here. So you get x prime into this is equal to 0. X prime into x prime 0 plus I divided by m omega, into minus I h cut del by del x prime of x prime 0 equal to 0. Alright? Alright. Which implies that x prime, here you have a minus I square, that will be a plus 1, h cut by m omega plus h cut divided by m omega del by del x prime 0 equal to 0. And for the time being, let's call h cut by m omega as square root of h cut of omega is x0 square, x0, just for a length scale. H cut by m omega length scale, so you call it as x0. Okay? And you just try to, what is this length scale? You think about it, what is this length scale? In terms of your, you think about what sort of length scale is this? Okay? Alright, so I call it as x0, so you can write it as x prime plus x0 square into del by del x prime, the x prime 0 is equal to 0. And this is precisely a differential equation, we can solve that. And to do this, and for the time being, what I'm going to do is, I don't want to take all this stuff. So basically, this is nothing but x psi 0 of x, right? So I call it as just psi 0 of x prime. So I call it as psi 0 of x prime. So you have x prime plus x0 square del by del x prime psi 0 of x prime equal to 0. Or what you do is you take this quantity to the right side. So you get x0 square into del psi 0 of x prime divided by del x prime is equal to minus x prime psi 0 of x. Okay, so you can, this implies that d psi 0 of x by d psi of x is x prime. These are all x primes. Okay, d psi 0 of x prime divided by psi of x prime, which is equal to minus x prime divided by x0 square minus into dx prime. If you integrate, you will get, integrate both sides, you will get psi 0 of x prime, which is equal to ln psi of x prime, which is equal to x square by 2. So it will be minus 1 by 2 x prime divided by x0 whole square plus a constant. Or you can write, if you do it, you can write psi of x0 x prime, psi 0 of x prime, which is equal to, you can take that constant as some log c prime or something like that.